Hello and welcome back to another episode of Math with Sohn. Today we're going to be doing some AP Physics and we're going to be talking about gravitational potential energy in a variety of different forms, so I'm looking forward to it. Alright, so potential energy, I'm pretty sure, hopefully you've heard by now, that it is the stored energy possessed due to its position, and the higher up something is, the more potential energy you have. What you may not have had is the formula that is connecting it. Alright, so U of gravity. By the way, potential energy is a lot of times called U, is equal to the mass of the object times gravity times its height. Okay? So gravity can change depending on what planet you are on, but in most cases, gravity would be the 9.8 meters per second. But what would be determined for your potential energy, if you're falling, would be A, how high up you are, and B, how much mass you contain. Okay? Now, the weight of yourself, the mass you contain, doesn't actually mean that you will fall any faster, but it does mean that if something that you were falling, like that was falling on you, so to speak, was really, really heavy, it would hurt more, which is why it has more potential energy. All right, so a bowling ball would hurt a whole lot more than a paperclip if it fell on your head. And a bowling ball falling at a height of a building compared to a paperclip falling at the height of a building, both of those would actually be exponentially harder to absorb the pain. All right, so that's why mass matters and height matters. The overall problems are not that bad. We got a few examples, and one of which involves a pendulum, which is a whole exciting thing for me to do as well. So with that in mind, we got a 800 kilogram car is driving up a frictionless surface with a constant speed. That frictionless matters. It reaches a point of 20 meters above its starting point. It doesn't matter that it has traveled 40 meters to the right while traveling up 20 meters. The only thing it was fighting, because there was no friction, is gravity. Okay, so the gravitational potential energy, U at the top, would equal mgh. Well, U at the top, the gravitational potential energy, would be equal 800 times gravity, which I'm just going to be lazy and call 10, times the height of 20. So if we do 800 times 10 times 20, we would end up with a gravitational potential energy of 160,000 joules. That is quite a few. All right, that's a heavy car and it went up quite a bit. All right, what is the work required to drive up the incline? Okay, so a lot of times you think of work as the horizontal distance. Okay, and it is typically the horizontal distance if there's friction involved, there's something else happening. But a lot of times work is the overall displacement, and the displacement in this case that mattered was gravity. It didn't matter this horizontal 40 meters because it was a frictionless surface. So work is equal to force times distance. It also is equal to the change in kinetic energy if you watched the previous video, but in this case, we know our distance and we can figure out the force due to gravity. Okay? To do that, we need to figure out potentially how much of this overall stuff is the vertical component, excuse me. But in this case, it won't really matter as much because there was no friction. All of the work and energy went to going up this hill because none of it was lost due to friction. All right, so with that in mind, our work would equal our force. Our force is going to be mg times distance. Mass times gravity times distance. Normally, you would fill in a sine theta here if there is friction indicating we're going up a hill, so on and so forth. But in this case, it won't matter. We got work would equal our mass, which is 800, times our 10, times our distance of 20. So we would have 800 kilograms times 10 meters per second squared times 20 meters. It had to climb 20 meters up. The meters would cancel. You get kilograms per second squared, and kilograms per second squared will end up becoming 160,000 joules as well. Okay. Why does that make sense, and why does that confuse us all at the same time? And that is almost getting into a very new concept, well, not that new. Newton talked about it. Energy can neither be created nor destroyed. As you were going up this hill, you did work. And once you got to the top, you had potential energy. That potential energy, because it was frictionless, wasn't destroyed in the process of going up. So these, if there is no friction, energy is conserved and would be equal. And that would be known as the conservation of energy. It's going to be a whole different video as well.